example 3 is a balloon problem. They like this on the AP exam. A spherical balloon is filled to maximum capacity when the radius is 12 centimeters. The area is released from the balloon. So now we're not increasing the size of the balloon, we're decreasing the size of the balloon at a constant rate of 24 pi cubic centimeters per minute. Find the following. How fast is the radius of the balloon decreasing? Just a little aside here. I'm trying to find dr dt then. That's the question mark here. Decreasing at the moment the radius is 9 centimeters. Okay, so first we need to find a formula that works for us. There are some expectations. You need to know the areas of simple figures like a circle, the circumference of a circle, the volume, a lot of volume formulas, volume of rectangular prisms, volume of spheres, volume of any like a box is a rectangular prism, things like that. Cones, pyramids. Those, if you are shaky on those, please make sure you look those up. So the volume of a sphere is 4/3 pi r cubed. For those of you guys that are not sure. Okay, same with, oh, by the way, a cylinder as well, you need to know. For us then, I know I have to take the derivative with respect to time. So we're going to take dt of v of both sides, whoops, I don't know, too many of those, dt of 4/3 pi r cubed. And then remember, pi is not a variable, it's a constant, so it works just like any other constant or coefficient. On the left-hand side, I get dv dt. On the right-hand side, I get 4 pi r squared, which, by the way, is the formula for the surface area of a sphere. The surface area of a sphere, if you think about it, if you're increasing the volume of a sphere, it's like you're adding one full surface area infinitely many times to increase the volume. And the same with decreasing, you're shaving away one surface area at a time. So that's why these are related, just like the ripples in the lake from before, dr dt. So here's my formula. Now I have to state, okay, when, so that's the instant I'm interested in, when r is equal to 9. And some things that I know for sure that's given. I am given dv dt, the volume is changing at a constant rate of 24 pi cubic, but it's decreasing, so that means the volume is negative. The volume is going down. Cubic centimeters per minute. So now I just have to substitute in. So I'm end up with negative 24 pi is equal to 4 pi times the radius is 9 squared dr dt. I'm going to divide both sides by pi, which is easy enough. Divide both sides by 4. I get negative 6 over 81 is equal to dr dt, which reduces some more. So dr dt should equal negative 2 over 27. So first you're going to ask yourself, does it make sense that the radius is negative? Well, because it's deflating, then the radius of the sphere will also, it makes sense that it's going to get smaller. And it's a length, so the units for this would be centimeters per minute. So the radius of the balloon is decreasing at a rate of 2 over 27. So I said decreasing, so don't make it a double negative. Decreasing at a rate of 27 centimeters per minute, not centimeters cubed, it's centimeters because it's a length now, And then we have to write when the radius is equal to 9 centimeters, because it's not all the time, it's just when the radius is 9 centimeters. How fast is the surface area of the balloon changing at the moment the surface area is 324 pi centimeters squared? So surface area for a sphere is 4. So the area, the surface area, I'm going to put a little s for surface area down here. 4 pi r squared is the formula for that. And I want to find d dt of the area. So I'm going to have to take the derivative with respect to time on both of those. So dA dt is equal to 8 pi r dr dt. Okay, and it's saying how fast is the surface area of the balloon changing at the moment the surface area is actually 324 pi centimeters squared. So that's the instant. That's after I've created my formula. I'm going to write up here when surface area, the area of is equal to 324 pi. And for me to, the formula I have for the rate of change of the surface area, number one is based on, right here, is based on the, what do you call it? It's based on radius. That's what you call it. Sorry, I had a moment. So I have to find the radius at the time that the surface area is 324 pi. So I'm going to substitute in 324 pi in the surface area formula, 4 pi r squared. So r squared is equal to r squared is equal to 4 into that is 161. So like 161, no, 81. Hello, I'm really on a roll today. 81. So that happens when the radius is positive or negative 9, but the radius cannot be negative. So then it's just going to be positive 9, right? Oh, wait, I know I have found above the RDT when the radius is 9. So from part A, we know dr dt when r is equal to 9 is equal to, what was it, negative 2 over 27. So I need to utilize that to be able to answer the question, because it says how fast is surface area changing? Okay, so dA dt is then equal to 8 pi. The radius is going to be 9 at that time, but I have to check. I had to substitute in. And then dr dt at that time is 2 over 27. Now on the AP exam, you would be done here, but this is not the AP exam. So let's see. Does it simplify a bit? I think, yeah, 3. So that's going to give me negative 16 pi over 3, I think. And that's its surface area, so that's square centimeters per minute. And it's decreasing, which still makes sense because the surface area would also get smaller as the balloon deflates. So that means the surface area is decreasing at a rate of, now I'm using the word decreasing, so I'm going to write 16 pi over 3 centimeters, square centimeters per minute. But don't forget to write when, because it's only when the surface area is 324 pi square centimeters. So now we've answered the question asked.